In this video, we present a system that combines augmented reality, virtual reality, and 3D scanning to allow people to collaborate on physical activities while being at a distance. This video will present 5 different types of features, but first we'll present the technology. This is the most basic setup involving 2 collaborators. Person A can be at home or in a makerspace manipulating physical objects, and they're being watched by a 3D camera, such as a Kinect sensor. The other person, person B, is at home watching the space through a computer screen. This person can virtually move around the space and communicate with person A through features that we will show later in this video. In the rest of this video, everything you see will be from the perspective of the user who's connecting through the computer. A current limitation of the system is that there's a shadow behind objects, and that's because we're only using one 3D sensor and cannot see objects in the back. And another limitation is that on the edges of objects, there's a fuzzy aliasing, and that's due to the 3D scanning quality. So please ignore these for this video. The first thing to show you is features for remote collaboration. In this case, 2 people are going to collaborate together. The makerspace user has some physical pieces next to it, and then the remote user can look around this space by just looking from different angles. They can also collaborate by being able to point at objects or to create drawings in order to indicate how objects should be moved. So for example, taking that side and putting it over here. And in this case, the remote user is guiding the person in the makerspace in the assembly of this tangram puzzle. So in this case, different objects need to be moved in different ways in order to build this stick figure. And it looks like they're almost done, so the head needs to be put in. But now the remote user would like to use these physical objects in order to modify this tangram piece. So you can guide the makerspace user to put objects in specific places, or even to take one object and put it on top of the other object. The ability to see things in 3D allows this kind of interaction. And we can also use real physical objects. So in this case, this is a 3-dimensional physical lamp that's in the makerspace, and the remote user can communicate in order to build things in 3D. So for example, to connect that side of the tangram puzzle to that side of the lamp through perhaps a ramp. So in this case, we're using a ramp to connect the two, and because this is a 3-dimensional scan, the remote user can look around in 3 dimensions to understand the layout of the space. Since this is a virtual environment, we can change the way the environment looks. So in this case, this is a 3D scan of a real makerspace at the Harvard School of Education. And by placing these users and this collaboration in this space, we allow people to feel like they're in a real makerspace. For the next portions of the video, the makerspace person will be wearing a Microsoft HoloLens headset. This is an augmented reality headset that allows them to use their hands in order to interact both with physical objects as well as virtual objects. So as you can see, once the augmented reality headset is being put on, the system can detect people's hands. And what they can do now is you can pick up these virtual objects and put them in a scene which contains both virtual and physical objects together. And so the makerspace user can pick up these virtual objects. The remote user can point to where they want the object to be. The virtual objects also interact with each other. As you can see, they have physics, and they can be picked up and rearranged. And the physical object that's there is a lamp, but the remote user wants to modify it to become a monster. So for example, to have these eyeballs and have some antennas and a mouth. So through these annotations, they can communicate with the person in the makerspace, and then the virtual objects can be picked up and be added to the physical object. So in this case, the 2 virtual eyeballs are being added to the lamp and to the diagrams that have been drawn on it in order to create this monster-looking thing. So through this collaboration, there has been a scene that was created which contains virtual objects and real objects. And more virtual objects can be added to modify the real lamp. This kind of system also allows virtual elements to be overlaid on top of physical objects. So in this case, we're going to be debugging this electronic circuit. And what the system can do is it could measure things in real time, so to show electricity at the points where contact is being made, but also to show the paths of electricity overlaid on top of the real circuit. These virtual overlays can be applied to three-dimensional objects. In this case, we're showing the physics of torque, which is a force that's created perpendicular to the two white vectors. With this kind of system, a student can change the camera angle in order to understand how these forces occur in three-dimensional space. We can also remove the real world in order to focus the student on abstract representations and show that the same diagram applies to different physical objects, for example, in this case, a hinge. In this case, we're going to be using the virtual overlays to learn about this robot. The robot has proximity sensors on the sides. So over here, it has proximity sensors that detect distance. And we can visualize these using these virtual overlays that show when the hands are being brought close, what the sensors are actually picking up. And we can also bring in a circuit diagram that shows what's happening inside of the robot circuit. And in this case, we could detect what happens to the sensors and highlight what happens inside of the circuit as the different sensors are being activated by the user. A person who has a virtual reality headset at home could join into this virtual environment also. In this case, we're going to show two people who have virtual reality headsets be talking to each other about a circuit as the circuit is manipulated live. And so you can see with virtual reality, people's hands and head motions are being tracked. And so this creates a much more immersive experience in which people can collaborate. And in this case, you can see a person in a makerspace who has augmented reality collaborating with a person at home who has virtual reality. They're talking about objects that are physical and virtual. And the person who's observing them can also draw or do other kind of gestures to communicate with these people also. And so through these facilities, we allow people to connect with many different devices into the same shared space. And this creates a much more intense feeling of being present with other people and can create a sense of community. This kind of technology also allows us to expand on more traditional approaches. So, for example, in this case, we might have a two-dimensional whiteboard that allows us to collaborate in a 2D with 2D drawings in this virtual space. But this whiteboard might be too simple. So we might be able to create three-dimensional interactive visualizations that allow an instructor or students to explain something that's happening in a more three-dimensional way. And we can bring these diagrams closer to physical objects so that the theoretical explanations are close to the physical objects that they are about. Finally, we could also use digital models to explain how fabrication tools work, and even present this to a classroom of students who are all connecting remotely. If you want to learn more, or if you want to help us expand this system, please reach out to us. Thank you.